Computers today are easier than ever to use. Gone are the days of monolithic machinery filling up rooms, needing to be programmed through pure numbers and only understanding arcane commands. Instead, we have small personal computers that can fit in the palm of your hand. Rather than programming them through machine code, we can use higher-level languages, and instead of using commands, we can interact with our computers graphically. These developments all came in part through the efforts of the researchers at Xerox PARC. In the early 1970s, Xerox, fearing their copy machines would become outdated with the rise of personal computers, decided to finance the development of a paperless office. Among the many new technologies developed there, the most famous is the Graphical User Interface, or GUI. Before GUIs, the only way you could perform actions on a computer was by typing in commands with very little room for error. The GUI set out to change this by replacing the commands with motions performed by the user through the mouse. Despite being revolutionary to human-computer interaction, the main reason the story of the GUI is so well known by those in the computer science field is because of the legendary story of how Xerox simply gave away their fascinating new development to Apple, because Xerox management couldn't see the potential. Apple did end up introducing GUI to the public, but there were other technologies also being developed at Xerox that even Apple didn't see the potential of. One of these developments was object-oriented programming. At the time, compilers and interpreters did exist, allowing code to be written in something other than machine-specific CPU operations, but whenever something needed to be changed in the program, it was possible that the change might require edits to be made in many different parts of the program, making coding difficult and more prone to errors. Object-oriented programming sought to fix this by separating important components of the program into things called objects. While data structures that held more than just numbers, as well as separate subroutines in code to perform complex actions both existed, object-oriented programming combined the two. Each object could have a data structure and subroutines to perform, and when they were performed, they usually would refer to the object that ran them. Think of a program running in a window. The program itself can hold data and perform specific actions with its data, while another window, even if it's the same program, can hold different data and perform specific actions on that data. The real benefit from object-oriented programming comes from the ease of switching out objects. Suppose you need your program to perform a different calculation, or to output to a different location. Rather than modifying the whole thing, all that needs to be done is to modify the object that's responsible for the action. PARC realized the potential for this and developed a language called Smalltalk, based on a previous language called simula that introduced the concept of object-oriented programming. While Smalltalk isn't as commonly used today, other languages such as Java, Ruby, and Objective-C were influenced by the design of Smalltalk. Another development of Xerox PARC was a network standard known as Ethernet. Based on the Hawaiian network Aloha Net, which greatly simplified network interactions between computers, Ethernet provided a standard wired connection for local area networks. The name Ethernet itself is based on the antiquated belief that outer space contained matter known as ether that conducted light and other electromagnetic emissions, if they were indeed a wave. Thus, the standard that provided a conduit for signals that were originally transmitted over radio waves came to be known as Ethernet. While Smalltalk eventually saw itself become overshadowed by more powerful languages, Ethernet only seemed to grow more popular with time. One of the main draws was that Ethernet wiring was much simpler than other protocols of the time, such as IBM's token ring system. Apple even tried to develop their own network standard, called LocalTalk, rather than use Xerox's standard, but found it to be mostly ignored in favor of Ethernet as well. Ethernet itself is still used today, only seeing some competition with the wireless standard Wi-Fi. While Wi-Fi is becoming more popular with the continued rise of portable devices, it's unlikely that Ethernet will be replaced completely, as physical connections continue to be much faster and more reliable than wireless ones. You may not normally think of it, but many of the computing tasks and features we take for granted today have their roots in research done at Xerox PARC. After the interaction with Apple in the early 1980s, PARC didn't stop continuing their research. They continued to develop all sorts of computing ideas and technologies, like optical storage, handwriting recognition, data encryption, data visualization, and even concepts such as ubiquitous computing, the idea that computers would find their way into everyday appliances. Xerox PARC will probably always be known for one of the biggest mistakes of the personal computer industry, giving away the graphical user interface. But with all of their other successes, it hardly seems fair to recognize them for that one big blunder.